This conference will now be recorded.
So, good morning, everyone, and welcome to a fresh new session on credit risk modeling using science. And what we do is we will do a very quick recap of the discussions which we were into in the last class, and from there we will take it up from the next. So we will take it up from the next discussions, right? So, in the last two classes, we were discussing about the detailed data quality check exercises, right? So we were trying to understand how is it that a scorecard is developed. What are the stages that we follow while developing the scorecards, right? So as a part of that, we have talked about the concept of data extraction. We have talked about the concept of scope analysis. So scope and gap analysis followed by data extraction, and that followed by the data quality check. Okay. And over here in the last class, we were talking about the data quality check exercises. So what are the key checks that we need to do as a part of data quality exercise? So when we talk about the data quality check exercise, right, so we said that broadly there are three big analysis that we need to do. Now, one of the analysis that we needed to do was simple missing observations analysis, right? So we needed to know whether the records or whether there was any missing observations in any one of the key records in the discussions, right? So we needed to know. So basically, if I have say around 100 variables, which I have obtained after completing the basic checks, right? I need to know whether these variables have any missing values or not, right? So therefore, what we needed to do is we wanted to understand whether or what were the if there was missing observations, what were the percentage of the missing observations and so on. So, after having done the missing observations exercise, the next check that we started talking about was assessing whether the whether the continuous variables have a proper trend or whether they have any unusual trend or not, right? And how is it that that can be identified, right? So over here, while we talk about in today's discussion, we will be focusing more on this part, right? On talking about the long-term trend, we'll talk more about the frequency distribution analysis and so on. So our objective over here would be to undertake a stage-by-stage description of the data quality check exercises, right? So we have been discussing the initial parts of data quality check exercise in some of the previous sessions. So in today's discussion, we will take that up on a more full-fledged basis, right? So let's start off with the major checks, the major data quality check exercises that we would be performing. So the first check that we have over here. So just let me, before we move on, just let me create a summary of the quality checks that I would be doing over here right from the beginning. The stages of developing the scorecard. So the stages that we have been following for developing the scorecard till now. And from there, we'll take it up one by one. So the first stage of scorecard development is the scope or the gap analysis. So in the scope of the gap analysis, our objective was to ensure that the scope or the gap analysis. So in the scope of the gap analysis, our objective is to ensure that we have a proper reason to develop the scorecards. This part comes with the business justification. Right? So that's the first step that is there. Now, the next part that followed this was the data extraction. Just give me a second. Data extraction, right? So the next part after data extraction was the data quality checks. Data quality checks. So these are the first three stages of developing the scorecards, right? Now, once we have developed that, so once we have gone through these first two stages, so at the end of these first two stages, what do we have? So over here within data extraction, we also had another step of dependent and the independent variables that we needed to identify which are the dependent and the independent variables. Slash independent variables. So after we have actually identified all these steps, we come to the data quality check. The objective of the data quality check is to assess the quality of the data and to ensure whether the data is of a substantially good standard or not. Good standard or not. Good standard. And the standard that we generally tend to achieve for model development is that of a gold standard. Is that of a gold standard. So the question that comes out over here is that what do I mean by a gold standard data? So by gold standard, what we mean is it's a data which does not have any missing observations, which is no missing observations, which is no missing observations. Second is which does not have any uh, no unusual trend in continuous variables. No unusual trend in continuous variables. In continuous variables. And finally, the third part is no unusual concentration. No unusual concentration in categorical variables. In categorical variables. So these are the three broad characteristics that a gold standard data is expected to represent, right? So how do we do this, or how do we ensure that a data is of a gold standard? Now, to do this, we perform a trend analysis of each of these. So as a part of our exercise that we do over here, we will use a trend analysis. Is a trend analysis. So what we need to do is, for each of these cases, we need to perform a trend analysis, and we need to check whether there is any kind of challenges or any kind of abnormal behavior which comes up in this case. So over here, if you have a look into the missing observations. So what is missing observations? Missing observations are very simply observations which are missing from a variable. So let's have a look into this missing observation analysis first. In a missing observation analysis, all we need to identify is the percentage missing observations, right? So when I say it's percentage of missing observations, so it gets defined like this: number of missing observations. The number of missing observations. So it's number of missing observations divided by the total number of observations. Divided by the total number of observations. Divided by the total number of observations. Now the question that comes out is, the question that many people ask is, so with missing observations there are two challenges that come up. First challenge is how to identify missing observations, and second is how to treat the missing observation, which is obviously a bigger question. Right? So the question that comes out is, I may get some missing observation, but how to treat the missing observations? How do we treat the missing observations? how do you treat the missing observations? Do we treat the missing observations? Right. So now, before we talk about how to treat missing observations in a data, let us try to understand, the cases. So, what we need to do is, before we understand how do we treat the missing observations, we need to, kind of understand how is it that the missing observations originate. Right? So, how does a missing observation originate? What are the different reasons because of which an observation or a missing observation is noted? So, when we say this, so let's think about it in this way. Now, an observation is missing when an observation is not there. Now, what are the reasons as to why the observation can be missing? Now, first, one major reason is that observations may be missing because of negligence. That the person who was working with the observation was, who was entering the data, because it was because of his negligence that the observation is missing today, right? So, from this perspective, when we talk about the missing observations, what we do is, or what we need to do is, so from the perspective of missing observations, what we need to do is, we need to understand the reasons. So, let's first of all create out the reasons for the missing observation. Reasons for missing. The first reason as to why a missing observation can occur is because of negligence. Is because of negligence. Now, what do I mean by negligence? Negligence means that while the databases were entered or while the data point was being recorded, it might be that the front end executive who was entering the data had missed out the observation, right? Or the second reason could be the system issue. And the system issue. So basically, so in both of these may result in an observation being missing just because of the fact that the number itself was not entered into the database. The number itself was not entered into the system, right? So that's the first. The second is the system issue, that there might be some system issues because of which the number was not registered over there. So you can actually club these two reasons together, right? So over here, how is it that you can identify, or how is it that you treat this missing values. Now what matters over here is that under which observation or what kind of variable has the missing. Now over here, mm, one way to treat this is that if you do not get the values in your file, that's the file, the SAS files that you have, which your data preparation team has prepared for you, what you do is from this base, you just go back, right? So from here, you just go back and you try to identify from the source files what the values are. So basically, if the variable values are missing, try extracting them from the source files. Extracting them from the source files. Try extracting them from source files. Say for example, what are the cases when should you try to extract the missing values from the source files? You will do that, and that becomes absolutely necessary if say the missing is in critical variables. If the missing values arise if the missing values arise for critical variables. For critical variables. Right. So if the missing values arise for critical variables. So if the values are arising for critical variables, so what are the type of critical variables that we are talking about over here? Now the type of critical variables that we talk about over here is ID variables. ID variables. Second is limit variables. Balance variables. And the key categorical variables. Now, when I say key categorical variables, what do we mean by that? So by that, what we mean is variables like product type, gender, etc. So these are some of the important variables that, if missing, we need to look up and we need to understand as to how these are missing. So are these variables present in the source file or not? Ideally, for ID variables like transaction ID, variables like transaction ID, The transaction ID is an ID variable which is relevant in the retail domain, or it is also relevant in the commercial domain mostly, right? Where you have multiple transactions actually occurring. So in the retail portfolio, transaction IDs are mostly known as account IDs. Account IDs, right? Now, then what you have is information on customer IDs and any other such ID variables, right? So now the point that comes out over here is that you know one particular customer ID or an account ID may be missing. Let's say goes missing in one particular month. Let's say I have. Let's consider this case. Okay. See my data. I'm building up an arbitrary data. Okay. It's like 2016-01, right? And I have an account ID. I have an account ID called 210333, right? And what I have is a customer ID. And the customer ID is 345. I have the customer ID as 345, right? Now, this ID is available, is seen to be available from 2016 Jan to 2016 June, right? In 2017, in in July 2016, so in 2016-07, now the account ID becomes account ID is missing. But that particular customer ID still exists. So it means that all the transaction has happened corresponding to for this customer in this particular account ID. But the account ID is this particular account ID is missing. Now ID variable is a identification variable. Now given that an ID variable is an identification variable and we cannot impute it by anything else. So what we need to do is we need to actually go back and we need to check whether as to why this ID value is missing over here, right? So over here, when we say that the account ID is missing, so I don't have any other options but to go back and check as to why that account ID is missing over there. And I need to extract this ID from the source file. So this is something which cannot have any other imputation apart from going back and extraction from source file or lookup from the source files. For the source files. Lookup for the source files. So this is precisely what we would actually want to do. We would like to look up the source files, and from there we would like to extract the information. Clear? So this is a particular case of imputation on missing observations where you can do nothing but look up for source files. However, ideally this ID variable should not be missing, or a particular ID may be missing after a point of time. So if I am merging, if I am trying to fetch out one particular ID after a point of time, you may see that a customer ID may exist, but the account ID may not exist. Can you tell me when can this happen? So a particular ID may go missing over a period of time, right? So how would you see that particular transaction? How do you think that particular transaction would have happened? Or why would that particular transaction would have happened? Now, this happens in the case of a top up. So basically, let's say I have a particular loan product which is going on with the bank. Now, what happens is I take a particular top up, right? The bank provides me a top up. So basically, the loan's principal amount and the EMIs do get impacted, right? So that ID is first closed and a new ID is actually created, right? So when you take a loan ID, when you take a new loan, right? So then that's called a account ID. I mean, then what happens is a new account ID is generated, right? So that ID is closed and a new top up is generated. Okay, so what I'll do is I'll just explain this point again. Let's say there is a borrower who had taken up a personal loan, right, and the loan has been operating in the books of the bank for the last 3 years. Now, what happens at the end of the third year? He wants to go for a top up. Now, when this guy takes a top up, the last account ID that he had is closed, and a new account ID is generated, right, against that customer ID. So if by a customer ID you are trying to pull out the particular account ID over a period of time, then after a point of time you may not get this given account ID. This account ID may be changed somewhere. And what happens is that in the event of change, when this change happens, there may be a gap or there may be a system lag which might be there, and hence an account ID may go missing in a particular month, right? So the system may take time to update all the new account IDs, right? So ideally that should be done, but there can be system issues, there can be process issues because of which there may be a lag. And if there is a lag, in such a case, account ID may go missing. In that case, what you need to do is, if this kind of a situation happens, you go back to the source file and you check whether that account has undergone a top up or not, right? This also happens for cases, when there are credit limit increases. So the first credit, so a new account ID may be generated against that borrower with the new limit and the new product, or not mostly for credit limit increase in credit card. This happens for product upgrade. So suppose I was using a mass product, now I have gone to an advanced product. When I'm doing this upgrade, the account ID may change, and there, due to system issues, there may be a lack of reflection in a given month. Say basically the time when I extracted the data, right? That information was not there. But when and the information was updated later on. So at that point of time, the account ID may go missing because of system issues, right? So in such a case, the source file needs to be looked up. In the source file, if you find any account ID changes has happened, right, then you need to check up whether any top up or any product upgrade was done or not, and if that was done, then from there you need to accordingly identify the account ID. So this is one case as to when the observations can go missing. Clear? Great. Any questions up to this point? Okay, great. So this is one sort of missing observation. Now the next set of missing observations is, okay, so the next set of missing observations can happen because of, you know, codings or because of the way a variable is defined. Let's say I have a variable like date since last delinquency, since last delinquency, right? So this is the next part. So date since last delinquency. Now date since last delinquency is a variable which is uh, kind of populated if and only if you have been delinquent at some point of time or the other, right? So date since last delinquency was the variable which is populated if and only if I have the last, you know, if and only if I have been delinquent some point of time. Now, if I have been an ever non-delinquent borrower, if I have been an ever non-delinquent borrower, ever non-delinquent borrower, then this particular variable will always be missing in nature. The date since last delinquency is applicable only to those accounts or would have a finite value for those value accounts where an account has been delinquent at least once in its entire history. And if I am someone who has never ever been delinquent, then I will not be, then the date since last delinquency will be missing. Right? So, how do you think we can treat this particular kind of a missing observation? So, to treat this kind of a missing value, what we need to do is we need to. Uh, so, what should I do? So, one way to treat this is to identify some special values, some default date values. So what I can do is I can put in some default dates. Say, what I can say is that if the borrower has never been delinquent, right, then what you put is a date like 31 December 2099. So whenever I see that an account is non-delinquent, has been ever non-delinquent, and they do not have any kind of, you know, and they do not have any kind of missing, I mean, they have never missed out on any payment, and they do not have a date since last delinquency. So what I do is I substitute those accounts with those dates with 31st December 2099. Now, this will help me do something. So, what does this actually help me do? It helps me impute those missing values. So, whenever I see that the date is 31 December 2099, I know that this is the base, or these are the accounts which have never ever gone delinquent in their entire life, right? So this is the way we can solve this kind of a missing imputation case. Now the second case that I say, or this date since last delinquency that I talked about, is that the missing values have happened because of the missing observations over here has happened because of the way that the variable is defined, right? So that arises because of variable definition. So this is the second case, that a second type of missing observations, or second reason, second set of reason due to system issues, and due to variable definition. This is the way that the variables are actually defined. Where the variables are defined. So is this part clear? Now there can be many such variables like this. Not only dates is last variables, there can be variables like um, there can be variables like payment balance ratio. The payment balance ratio. So what is this payment balance ratio over here? The payment balance ratio over here states that, so payment balance ratio is the payment made in a cycle. The payment balance ratio. So the payment over here is, so basically the payment that I made on a credit card in a given cycle divided by the balance that I have outstanding in a given cycle. So that's the payment balance ratio. So how much do I pay back as a proportion of the balance, right? Now let's say I have not used anything. My balance is zero, so I'm not paying back anything. So it is a 0 by 0, and this is a value which is numerically undefined. Now, if this value is a numerically undefined value, the payment balance ratio will take a case of missing value. So it will arise as a missing in the data set. So in such a case, right, the payment balance ratio is given a specific value, which is a special value, which is like 9, 6. So I have given the value is as 999999. right? So this is a very specific value that this payment balance ratio will have, right? Now, so this is a very special value. So when I'm computing the payment balance ratio, these are the values which have to be taken out, right? And the remaining needs to be computed, because there is no point in taking these accounts which have not used the balances, do not have any balances, we do not have any payments, because these accounts may turn out to be inactive in the future. So there is no point in using these. Therefore, the payment balance ratio is something that we need to use over here, right? So this is precisely what the payment balance. So this is the second case where missing observations arise, right? Now in this case you can impute. So one very important observation that we tend to get from here is that not all missing observations are imputable. I cannot impute all the missing observations. Now missing observations can be imputed basis their requirements, basis the way that they have, you know, basis the way that they have evolved, this is the way they have occurred, right? Any questions? Great. Okay. Now the third case. Now often, what may happen is limit variables may be missing, right? However, limit variables are something which should not be missing in the data. Right. So if limit variables are missing from the data, so limit variable is an account level information, and that needs to be tracked back to the source files, and from there it needs to be extracted. Right. So because limit variable, balance variable, these are very basic account level information. Right. Now statistical imputation arises in cases where you may not, where you go back to the source files for continuous variables and you do not get the values over there. So if it's a system, if it's an extreme system issue which has happened for a continuous variable, then you should go about and do missing imputation using statistical methods, because one reason as to why statistical imputation methods is not, I mean, would not be encouraged in risk modeling, especially in regulatory risk modeling, is because statistical imputation looks into the overall distribution, whereas most of the variable values that we have in risk are your, uh, you know, it's kind of your account level information. So therefore, if you are actually using the overall information, so overall what we have over here is the statistical distributions, right? So basically, if you're using a statistical distribution to impute a missing value, then what you are doing is you are kind of using, so you may be losing out on information, because every information, every variable that we have mostly in risk, are account level information, right? So they need to, if they are missing, they need to be extracted from account level information in the source files. Now, if information is missing from the source files, we have two uh, actions to take. One is to drop that observation from the data, or to do some kind of statistical imputation depending on the feasibility of each of the methods. Now, one challenge of statistical distribution is the statistical distribution uses the overall variable nature of the distribution and hence does the imputation. On the other hand, when we are doing this, when statistical distribution is imputation is done, you may lose out on information. You will lose out on information. So you may lose out on information. Hence, statistical imputation are, kind of suggested at very specific, under very specific cases based on need, but in general, it is not suggested, right? So therefore, what we would always, or what we would mostly do is, we would go out and we would do a statistical imputation for a missing observation if the need arises. Otherwise, the plain card treatment is, if you have missing observation in most of the variables, then you just drop that observation. Now, if a variable has missing observations, huge concentration of missing observation at multiple points of time, right? Then they are dropped. However, if they are very critical variables, critical to model variables like ID limit variable, balance variables, key categorical variables like product type, gender category, and so on. So in such cases, we need to develop these. So in such a case, we need to actually ensure that the distribution. So in such a case, we need to ensure that the appropriate account level information is extracted from the source files, right? Yes. Now, as far as statistical imputation is concerned, it is using the mean or median or mode for imputation. But at the same time, you may be, because these are all descriptive central measures, you may lose out on exact information. So when you are doing your imputation, you need to ensure that the imputed value is actually very close to the actual behavior, right? Okay. So the next part that we need to talk about is, there may be important variables which are missing observations. Let's say for personal loans, right? For personal loans, a very important variable is your EMIs. For personal loans, for personal loans, a very important variable is EMIs, right? So EMIs stand for equated monthly installments, right? Now, when you are using data over a long period of time, say you are using data starting from 20, 2006, 01, 2016, 12, let's say. right? Now, one challenge is that in between there may be time periods. Let's say 2008, right? 2010-06, 2010-07, and 2011-08. 2011-08. So these are 4 months where the EMI variable was missing, right? But the others, for all the other months, you had your EMI variables populated, right? Now, EMI is missing in these 4 months and it's 100% missing. The variable doesn't exist there. Now, how do you do this? Now, how is this now created? So, obviously, if EMI is a very critical variable, you cannot drop that variable. It's as simple as that. In any possible way, it's not possible for you to drop that variable. So, what do you do? What you do is you reconstruct this variable. You know that EMI is an amortization case, right? So you compute the EMI value. So to compute the EMI value, you need the amount variable, you need the duration, you need the interest rate, and you need the number of compounding period, the interval within which the compounding is actually done. So the next thing that we do is we construct the EMI variable, and from this construction Yeah. So as I was saying, um, yeah. So in this case, what we would do is we would have the EMIs, right? So what we need to do is we need to recreate the EMI variable, right? Once that EMI is recreated, then we recreate the EMI for the periods when this variable is available. We reconcile the EMI values to the given EMI variable values, right? We compare the difference that exists between them, and from there, what we do is then we use that. If we see that the two variable values are coming very similar to each other, then we go ahead and use this newly created EMI variable to impute the missing values for this period, right? Say EMI is available for 2000. So apart from for these 4 months, EMI information is available throughout, right? Now, once that is done, what I'll do is I'll recreate the EMI variable following the EMI formula for some of these months, say from 2006-01 to 2008-07. Then for all the periods for wherever it is available, I create the EMI variable, right? Now for each of the months, I compare the raw EMI variable which was there in the data and the EMI variable which I have created. I compare their differences. So basically, I have two EMI for the information of 2006-01. I compare the EMI underscore C, which is the EMI created, and the EMI variable. And I compare whether the difference between the two is less than 5% or not. So if the difference between the two is less than 5%, 5% or less, then I know that okay, the difference, the two variables are more or less giving me similar values. Then with this EMI underscore C, I create the EMI for these 4 months. So this is another process of imputation, right? So you are not doing any kind of statistical imputation, but what you are doing is you are using the variable, you are taking up the account level information, you are recreating a variable, and from there you are trying to perform an imputation exercise, right? So this is another way through which missing observations can be handled, right? So we missed out on the voice connection for some time in the room for a couple of minutes. So is this part clear? Right? Okay. So this is the third way of imputing. Now coming, so these are the different ways through which missing observations can arise, right? Now I have just mentioned a few ways, few possible ways that they most commonly arise, right? But there can be multiple other ways as well. But broadly, these are the three ways. So one is due to negligence or system issues. The second is due to variable definition, and the third is because of system updates and so on. Uh, so these are the different reasons as to which missing observations come. Okay. So just to recollect on the last part, we reconstruct the EMI variable value, and with the available EMI variable value, we compare it for those months for which it is available. We check their differences, right? So for every month, once we do it, we can do a detailed distribution of the differences, and we can see how much is the difference like, what's the percentage distribution of the differences, and based on that, we can decide whether the two variables are similar or not. Now comes the question that how do I decide whether a particular variable should be kept or should be removed from the data, right? So how is it that the missing observations analysis must be performed in our exercise? So let's say I have a variable called limit, right? So I'll say a variable name is here. So over here in the var name, what we have is as follows. Let's say I have a variable limit, right? For this variable limit, so let's say this is a credit card data, right? And I have a variable limit. For this variable, on a month-on-month basis, I'll compute whether it has any missing values or not. Let's say I am using the data from 2006 Jan, also 2006 June to 2016 or 2017 December. Right? So it's 2006-06 to 2006-07. Then I have 2006-08. So like this, it goes on, right? You know it like this, it goes on. Now, I would ideally expect that this variable should have 0% missing, and ideally it should have. Now, it would if it has 0% missing, it means that yes, it's an account level information, and this variable is correctly populated for all the months. Now, let's suppose from 2010 10 March to 2010-09 September. I see that there is 60% missing in all over, or let's say 100% missing. Now the question that comes out is that if this is the case for any other variable, I could have easily dropped this variable, saying that this variable has missing values at multiple points of time, hence I'll drop this. But this is a limit variable. This is an account level information, and for credit card, this is a very basic variable because you require all many of the derived variables to be calculated from this variable. Okay. So for limit, I cannot do this because limit variables there are 100% missing values, right? So limit variable is a very basic variable, and it would be used for it would be used for computing all other basic types of variables, right? all other covariates like utilization. You may use this to compute headroom. So if this variable values are missing at any point of time, then it would be a very big challenge. I cannot drop this. So it means that I need to go back. It's an account level information. And when a credit card is issued, this information has to be registered in the system. So if it is not available with me, the SAS view files or the file that I have extracted, it means there can be some problems. It may be that the files from which during this time that I had access or that I had drawn using SAS, one, these files during these months may be archived, right? And they may be zipped. In the archive, they may be in the zip format. So they may be zipped. Now, if these files are zipped in, SAS cannot read zipped in files. So you have to unzip the files before you extract them. So you need to go back and you need to check why these variable values are missing. That's one. Now, if you see that the files are unzipped, right, but still the variable values itself is missing over there, then you need to go back to the source files and you need to check whether the variable values are there or not. And then you need to extract it from there, right? And then you should get a 0% missing in each of these months, and then you can only proceed to the next stage. So this is where the role of limit. So this is where the role of extraction comes in, because limit is a very basic variable, and on a month on month, if you look at the trend of missing observations, it has to have a 0% missing value. Like limit, say a variable like product code must have 0% missing. If it has missing observations, then it's a very basic fault. An id variable, it must have 0% missing. Or if it has some missing, then you need to check why it has some missing. Has it not been correctly extracted? So these are some of the cases. Also, this is how a missing observation exercise is done. So a variable is taken, a month on month the missing observations are computed, and a trend is created. Right. The next question that comes out over here is, hey, hi guys. Sorry, I was in. Right. So over here, what we have is, so a variable like limit will show, should ideally show 0% missing, and if it doesn't show, then we need to re-extract back, right? So the possibilities are that it can be a zip file. If it is not zip, the variable will be missing. Now, if it's missing, we go to the raw files and we extract that. So there can be certain data issues like these. However, depending on the criticality of the variable, the missing observations are investigated further, right? Say suppose I have some variables which are missing, some basic derived variable which is missing, right? So therefore, so when we are computing missing, or when we're doing the missing observation analysis, we take up each variable, right? On a month-on-month basis, we compute the missing values, the missing percentages. Like look into the trend of the missing percentages, and depending on the criticality of the variable, we investigate the reasons for the missing, they're missing. Now, if the missing happens because of the fact that a system issues or whatever the reason may be, those issues are fixed, right? And at the end of the day, we would expect the variables to have the key variables, the core variables to have 0% missing, right? Only then can we move forward, right? So is this missing observations analysis, the way the analysis is done, is this clear to us? Any question? Anshul, are you clear with this?
Yeah, yeah,
Okay.
I'm
Okay.
able to understand. Yeah, that's fine.
Okay. Okay. So from here, the variables which have missing percentage or which have missing observations at different months of time, if they are not critical variables, then those variables are removed from the analysis, right? So there might be certain derived variables which have missing values. So they're removed and those are created afresh when we are doing the covariate creation approach. So from the missing values that we have created over here, from the missing observations analysis, we remove those variables which have missing values, right, at different points of time, and only those variables with 0% observations throughout the time period. So variables with 0% observations throughout the time period. With 0% missing. So with 0% missing at all time points. At all time points qualify for the next steps are selected. Now, obviously, the caveat that if critical variables have missing observations, then they are verified and it's checked and it is ensured that they have 0% missing values, and then they proceed into the next stage. Let's say, for example, dates in excess will have missing as well as non-missing. So it is my responsibility to ensure that the special substitution is done and then the missing observations analysis is done so that I can explain that why the missing observation is there and why the probable imputation has been done.
Tanmay, I have a question here. So
Mhm.
basically, when we talk of a banking industry, so banking industry are supposed to be more sophisticated and more precise when it
Right.
comes for a question about data collection
Mhm.
and data preservation. So,
Mhm.
so is it so how frequent is it happens
See,
that
the
we have
probability is low.
missing?
The probability
Yeah,
is low, right? But when we talk about banking industry, let's say the US region, the UK regions, so these are regions which are very sophisticated regions, right? So banks in these regions are less probable to have these kind of problems that I'm saying. But again, there may be these problems. So these are not something that which we always test for. These are something which we need to keep our eyes and ears open about. So these checks are done in order to. So if you run a missing observation check on limit variables, you will see it's 0% missing, 99.9% of the time. But there can be a time when it's 0.01. I mean, when some values are missing, right? It may be because of the way that the data was archived that the problem is coming in, right? Because data can be archived in real messy ways, no matter how what bank it is, because they have certain data space limitations, right? Because which archiving becomes challenging. So archiving can be done in another extension form. So there can be multiple reasons, right? So these are just points of caution which we need to keep in our mind as modelers. So that's the basic idea,
Okay, 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 fine.
right? So I do not mean to say that this is going to happen every time, but these are certain controls which are actually we are putting in into our data to ensure that the quality is going out. Now, if you think about from a regulator's perspective, right? The regulator might come back and tell me that, oh, what have you done with your data? Your data is not good. So I can actually provide him the controls that see, this is the check that I had done. This is what I had done. This is what I had done, and so there is a flow, right, through which the variables are going down and my variable waterfall is getting created. And each stage I have reason to justify that why a variable has been selected and why is it a variable that has been rejected, right?
Yeah, right, right.
So that is the reason why these variables with 0% missing at all time points are selected for the next stage. Because in if you since I have been working with the Middle East banks for quite some time now, right? I had worked with the banks, so over there this kind of a problem is very frequent. They don't have proper data interfaces, proper extraction stages, and on top of that, we face a lot of different problems. So over here, what we try to do is we try to ensure that variables with 0% missing at all time points are selected. Because if a variable has some missing points, missing observations, then that's a challenge, right? No matter what the variable is. So therefore, we need to ensure that we only work with those variables which have 0% missing. Say, let's say, for example, date since last delinquency. Now, this is a date variable which is derived from some other date. So, from today's date and the date when the account last went delinquent, a day since last delinquency, the difference between the two dates is the dates is last delinquency, right? So, the account never went delinquent, it's a missing value. So, you can directly recreate the variable, substituting it with a special value. So it goes on like that, so that you have your controls in place to ensure, to tell the regulator, to tell the group that the model that you have built up has sufficient data controls. So a data quality check procedure is nothing but it's a set of data controls to ensure that the quality of the data is substantially good, it's a high quality data, and that the data is stable, which can be used for model development going forward. Clear? Does that answer your question, Anshu?
Yeah, yeah. That answers my question.
Good. Okay, fine. Now, of all these variables which have gone up, now all these variables which are selected, right? Now the selected variables are divided into two parts or four parts. One is the ID variables, the date variables, then I have continuous variables, and what I have is categorical variables. Right? So I have continuous date variables, categorical variables, continuous variables, and I have ID variables. Right? Now, out of this, the first two sets of variables they do not need any further analysis. All I need to ensure is whether they have any missing observations or not. Any further analysis. Right? So all I need to know is whether these variables have missing observations. Right? So they do not need any further analysis. Now the next part is continuous variables. So what are continuous variables? Continuous variables are variables which are, you know, variables like limit, balance, then you have EMI, then you have rate of interest, etc. So these are all continuous variables. Now for the continuous variables, we need to perform a univariate analysis. We need to perform a proper univariate analysis. Now, why are we performing a univariate analysis? Our objective again is to know whether there has been an abnormal trend in the behavior of the variable. So, univariate analysis, and what we wanted to know is whether there has been any abnormal trend in the variable's behavior. Right? And the categorical variables, within the categorical variables, we have the following. Concentration. And to assess the unnatural concentration or abnormal concentration across the categories, we'll look into the frequency distribution analysis. Have the frequency distribution analysis. right? So these are the three broad changes, or these are the three broad analysis that we would be performing in the next stage. So first, all the variables are passed through the missing observations and methods. Once that is done, then the variables are broken down into univariate and the frequency. And from there, what happens is we have the univariate analysis. So we have, so the variables are broken down into category continuous and the continuous variables we have univariate, and on the categorical variable we run the frequency distribution analysis. Clear? Okay. So this is the broad kind of framework of the story that we have. Now we move from here, we move into the continuous variables, continuous and the categorical variables, and with that we will be completing our data quality check exercise. Okay, let's do something. Let's take a pause here for the day, right? And let's do continuous and categorical variables tomorrow, and thereby complete the framework of the data quality check portions, right? So with this part, we'll have covered the scope analysis, identification of the dependent and the independent variable, and with that we would have covered the data quality check. So from here, what we'll do is we will take up the next part, which is the discussion on the continuous categorical variables tomorrow. Clear? Great. So let's catch up tomorrow and complete this part, following which we will be working with the next stage, which is on the model development validation. With that, we'll complete the framework of scorecard development, and that would be followed by the, the development of the scorecard across different stages, right? Okay. So thank you guys. Thanks a lot. Um, in For the next workshop, we have the second session of the next workshop, the you know the free sessions on the free session workshop on IFRS 9 tomorrow from 11:30 a.m. to 2 p.m. Thank you. Bye bye. Have a great time. Have a great weekend. Let's meet tomorrow. Bye-bye.